Hi everyone, in this lecture we'll discuss one more algorithm to solve the maximum subarray sum problem. So it's a very interesting algorithm. Let us see the intuition behind this algorithm. So we have -2, 3, 4, -1, 5, -12, 6, 1 and 3. Let's say these are the elements that we have in our subarray. So what we will do, we will maintain a running sum. Okay, so what we will do, we will take a variable current sum. Initially it is 0 and we will take a maximum sum that is also 0, let's say. So we will will start iterating from left towards right and we will try to update this window of current sum. Okay, what is the current sum I have formed till now? So if I go to this element -2, I can say okay, 0 plus -2, it is -2, and I can get some sum from the remaining part of the array. But what you can say is, if you combine some negative part with some, let's say, positive sum, the effect of this positive sum is going to get reduced because of this negative part. So instead of taking a negative sum to combine with the next part, what you can say, we will ignore it and we will make it as 0. Okay, but if somehow, let's say, you get a positive sum, maybe it is very small but it is still positive, and let's say you get some more positive sum from the remaining part of the array, the effect of this would be this sum is going to shoot up, this is going to increase. So what we are going to say, if your current sum at any point is negative, better ignore that sum and move on. Okay, so I just say, instead of taking -2, I will just accept 0 as my current sum. I'm not going to count -2. Now you go to 3 and you say okay, if I add 3 to my current sum, it will become 3, and the maximum I will also update at every step. So maximum is 0 at this point, but the maximum is 0 at this particular point. Okay, so we have included 3. Next time we go to 4, and 3 plus 4 is what? It is going to be 7. So current sum is 7, and the maximum sum, it is going to be also 7. Next time I go to -1, I say okay, let's include -1 in our sum, and we can say the current sum would become 6, but the maximum will not change. Okay, the maximum will still remain 7. Okay, so if you talk about only this part of the array till -1, you can see the maximum sum is still 7. But now we got a negative element. Okay, we included this in our subarray because the subarray is still positive and we can combine it with some positive array from the remaining part to make it a bigger positive. Okay, so what we go, we say okay, let's go to 5, let's include 5. Now the sum is going to become how much? The sum is going to become 11, and the maximum is going to become 11 as well. Okay, that's how we are going to do it. Next we go to -12 and see okay, if I include -12 here, this sum would become -1. It's better to ignore anything and just keep 0. Okay, we can say the sum till this particular point is 0, because if you include -12, the entire array goes negative, and it will not help if we combine this array with some positive array from the right. So it's not beneficial for us, and we already know what is the maximum till now. The maximum till now is still 11. Now we go to 6, so we can say the sum is now 6 and the maximum is still 11. We go to 1, we say the sum is now 7, 6 plus 1, and the maximum is still 11. Then we get 3 and we say okay, 6 and 1, 7 and 3, so it is going to be 10, but the maximum is still 11. But now let's say somehow you get an element 2, you say the current sum is 12 and the maximum is also 12. Okay, so if you stop at this point, you will get a maximum sum of 11. If you stop at this point, you will get a maximum sum of 12. So this is a very simple algorithm, and you can see it works in linear time. Okay, so this is the beauty of this algorithm, and it is a popular algorithm, and it is known as Kadane's algorithm. Okay, so we can solve this problem in linear time using Kadane's algorithm. Now let us look at the code for this problem. So what we can do, we can say we have a current sum that is initially 0. We also need to have a largest sum. Okay, that is, let's say, also 0. So for int I equals to 0, I less than n, I plus plus, I can say Let us add the current element to current sum plus array of I, and if this current sum goes negative, then we will reset this current sum to 0. Otherwise, current sum is positive, we are adding something to the current sum, we can say the largest is maximum of whatever largest we have till now, or if we are getting a new largest through current sum, we will update it. That's it. And finally, from here we can return largest. That's it. And from here we can say cout maximum subarray sum, we have array and we have n. Okay, so let us run this, and you can see we are still getting the maximum subarray sum as 11. So this loop runs in order of n time, and that's why we said this is a order n based solution. Okay, and it does not take any extra space like we did in a prefix sum approach. It also takes order 1 space. Okay, so in terms of time and space, this is the best possible solution that we can have for maximum subarray sum problem. I hope you really understood this one. See you in the next lecture.